Okay guys, so today we're going to be looking at tangents and normals, right? So the first thing we're going to look at is a tangent. So a tangent basically is a line that touches a curve at only one point, right? Now, sorry about that. Let me just get my pencil, it fell. Okay, so like I just said, a tangent is a line that will touch a curve at only one point, right? Now the point at which it touches the curve is called the point of tangency. So we're going to assume that this pencil here is the tangent and this is our curve, right? That it's been the tangent. So we have one drawn already, right? That blue line there. So you see it just touches the curve, and it touches the curve at only one point, right? So that's a tangent, and this is the point of tangency. Similarly, I could have shifted a little bit and have it like that. And where my thumb is would be the point of tangency, right? There's where it touches the curve. I could have shifted a little bit again, and the point of tangency would have changed, right? So we can shift it again, and point of tangency will change. We could have put it like this, or we could have put it like this, or like this, etc., right? So we have like an infinite number of tangents that we could draw, right? The most important thing is once it's touching the curve at only one point, it qualifies to be a tangent, right? So notice it's not cutting. Like if we drop the pencil there, right? Let me say this was our line, right? That's cutting, right? So it's just touch the curve, right? So the next thing that we need to look at is a normal. Now a normal is a line that is perpendicular to your tangent. Now perpendicular means it meets at a 90 degree. So for example, I could have, let's say I put this pencil here. The pencil could be the normal for this tangent. We could have it here, we could have it here, 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 or here. But most of the time for this differentiation course, what you're going to realize is that when we're talking about a normal, right, so the normal that we'll be talking about is the normal that starts at the point of tangency. So just for right, so for this course, you're always going to be talking about it like from here at your point of tangency. It wouldn't be from here or here, right? So that's something to kind of note. So this is actually the little note here for tangent normals, right? So I have a tangent. You see I draw this tangent a little different. This tangent runs this way. I should have probably labeled it, right? So this is my tangent, right? And this one here is my normal, right? And they meet each other at a 90 degrees. So that qualifies it to be a normal. And like I said, for the majority of this course, so I think all in this course, all of the normals that we're going to be dealing with going to be touching at the point of tangency as well, right? So it wouldn't be like one over here, although that will be a tangent as well, but we won't be dealing with ones like that. Okay, so I'm going to move on now. Right, so we just dealt with perpendicular lines that are perpendicular, right? So a normal and a tangent are said to be perpendicular to each other. Now we have a property for perpendicular lines, right, that make them so special. Perpendicular lines, their gradients are said to be the negative reciprocal of each other, right? So what reciprocal means? Reciprocal basically means you're flipping the number, right? So for example, let me just get my little scrapbook here. All right, so for example, say we have 3/4. The reciprocal of 3/4 will be, you flip that fraction, you'll get 4/3, right? So say you have a half, the reciprocal of a half will be 2/1, which is the same as 2. Say we have a number like 6, the reciprocal of 6 would be, when you flip that fraction, you're going to get 6/1. Sorry, this is 6/1. When you flip that, you're going to get 1/6, right? So that is what reciprocal is. Reciprocal is basically you just flip your number, right? So what we're saying is that for perpendicular lines, their gradients are said to be the negative reciprocal of each other, right? What does that mean? So if this was negative 3/4, the negative reciprocal of this would be positive 4/3, right? So if this is negative, it go back positive. If this is positive, it will go to negative, right? So it's a negative reciprocal. So you flip and then you take the negative or whatever it is. So if it's negative, it goes back to positive. If it's positive, it goes to negative. So let's do something like that. So we could work forward or backward, and it's the same rule, right? So if we have a quarter, the negative reciprocal, since it's positive, this will go to negative, and we flip that, we're going to get 4 over 1, which is the same as just negative 4. Right? We have negative 5. The negative of this will go back to positive, and we need to flip that, we're going to get 1 over 5. We have 2, right? So we have to flip that and put the negative of it. The negative of this will be negative, and this will be a half when you flip it. This is negative, so it will go back positive, so we don't have any sign. And this is a third, this will go back to being 3. Right, so that's basically what you need to know. The negative reciprocal of each other, right, if they are perpendicular. Alright, so moving on now. You might be asking yourself, so what does this have to do with differentiation? Now, sometimes questions are going to be asking you to find the equation of, the gradient of a curve. The gradient of a curve, or the gradient of the tangent, so gradient of the curve and gradient of a tangent is the same thing. And basically, it's the differential of the equation of the curve at that point, right? Now, I know that's something like plenty to kind of digest, but I'm going to break it down for you guys, right, with these examples. So we're going to move on straight into the example. So this is the first example here. Okay, so I need to take off this, right? This is a question from a textbook that I can change up the numbers, but it's not working for that little hence part, so I take off that. Alright, so the question asks us to find the gradient of the curve y is equal to x to the power 3 take away 3x squared at the point where x is equal to 2. Right? So they ask us for the gradient of the curve. Gradient of the curve or gradient of the tangent is dy dx. So we need to find dy dx to start the ball rolling. Right? So let me write down y. Y is, so I'm just copying over this, right? Take away 3x squared. First thing first, dy dx is what we need to find because it asks us for the gradient of the curve. So it's going to be 3x squared, 6x, right? But it asks us specifically at the point where x is equal to 2. So at x is equal to 2, we're going to substitute 2 into this equation here. Right, dy dx is equal to 3 by 2 squared take away 6 by 2. So 3 by 4 take away 6 is 12. 3 4s are 12, take away 12, which is equal to 0. Right, so the gradient, how good is seeing that? That's all. Okay, so the gradient at that point is equal to 0. So you can fix that answer. Gradient at point x is equal to 2 is 0. Right, so you just fix your answer there. And that's basically it. See, nothing difficult. I left out this hence part because it really wasn't working for this question. Like I said, this is just a question that I copied from a book. I just changed the numbers, right? So I take off that part. Right, so moving on now to our next question. So this question asks us to find the gradient to the tangent. Supposed to be find the gradient of the tangent, right? So let me just change that one time. This is be off. Right, find the gradient of the tangent to the curve y is equal to x squared plus 3x plus 2 at the point where x is equal to negative 1. Hence, find the equation of the normal at x is equal to negative 1. Alright, so we haven't bothered up with our hence part as yet, right? First thing first, what they ask us to find is the gradient of the tangent, right? We said the gradient of the tangent, gradient of the curve is dy dx. Right, so first thing first, to get the ball rolling, we need to find dy dx. So I'm just going to write down what y is. Right, so dy dx is equal to 2x plus 3. Right, they said to find it when x is equal to negative 1. So when x is equal to negative 1, we're going to substitute here, right? So dy why I keep putting dx, right? dy dx is equal to 2 by minus 1 plus 3. 2 by minus 1 is minus 2 plus 3. Negative 2 plus 3 is 1. Okay, right, so that's the gradient there. And the lighting is kind of bad. So I'll just kind of shift in to see if I could get the lighting a little better. Okay, so right, the gradient is 1, so we get that. So we get gradient when x is equal to negative 1 is positive 1, right? So we write down that. Then we need to find the equation of the normal. Okay, so right, now in order to find the equation of the normal, we need to have a point and we need to have the gradient of the normal as well as a point, right? So let's work out the gradient of the normal first. If this is the gradient of the tangent, the gradient of the normal would be so this is the gradient of the tangent, right? Because we say the gradient of the curve and the gradient of the tangent is the same thing. The negative reciprocal of this. So this is 1, we'd have to flip it, but 1 over 1, if you flip that, you're still going to get 1, right? And it reminds the negative of that. Since this is positive, so go back negative, right? Okay, so the equation is y is equal to mx plus c. So you have to know how to find the equation of a line, right? In order to do this, we have to have the m value, which is negative 1, and we have to have the c value, right? We don't have the c value, but we could find out the c value if we had m and we had a point, right? We have the x value for the point, but we don't have the y value. So the first thing we're going to do is work out the y value. So once we have a y and an x value, that's a point, and we have our m value, which is gradient, we can move on from there, right? So we're going to find the y value. So I just write down this, find the y value, right? This is what we're going to do. You gotta write down this, so this is just for notes purposes. Okay, so we say in the point x is minus 1, so we're going to substitute that in this equation here and work out what our y value is, right? So it's the same thing here. So I'm going to put negative 1 squared plus 3 by negative 1. So it's the same thing here, right? I just substituted negative 1. So y is equal to negative 1 squared is 1, minus 3 plus 2, 1 minus 1 is negative 2, or you can 0 here. Just double checking that. Yeah, you can 0 there. So we have the y value, we have the x value. So the point is 0 is our x and our y is minus 1, right? So x was minus 1, our y is negative. Our x was, oh shucks, I write this wrong. Right, our x was minus 1 and our y value is 0, right? So we have our point and we have our m value, which is our gradient value, which is 1. So we're going to substitute that now, see if we can work out our value for c and write down our equation. Okay, so I kind of run out of space there, so I'm going to write it in my scrapbook. Okay, so I'm writing here now. Okay, so we have our point, which is negative 1, 0. We have our m value, which is 1, right? We want to work out the equation of the line. Instead of x, we put in, instead of y, we put in 0. Instead of m, we put in 1. Instead of x, we put in negative 1, right? So we're going to substitute all those things. One by negative 1 is negative 1 plus c. Carry this across. This will give us 1 is equal to c, right? So now we write back our equation, which is y is equal to mx plus c. We're only filling out m and c, right? So it will be y is equal to, m is 1, so it's 1x plus c. C happen to be 1 as well. So this is our answer. Alright, so I'm just going to go through back this, right? Because this was a kind of long question. Alright, so we're going to start back over from the top. Just going to run through it back. Alright, so they asked us to find the gradient of the tangent to the curve, right? So we have our equation of the curve at the point where x is equal to negative 1. So we said that the equation, the gradient is dy dx. So we work out dy dx. They wanted it specifically when x is equal to negative 1. So we substituted x is equal to negative 1 and dy dx turned out to be 1, right? Remember dy dx is gradient, right? So when the gradient when x is equal to negative 1 was 1, which we also know as m value, right, from maths. Then they asked us to find the equation of our normal at the point x is equal to negative 1. Now if x is equal to negative 1, we need to find out what is the corresponding y value for that point, because remember our point has an x and a y, right? So this was the x, we need to work out what the y was. So we substituted it into this equation here, right, which is what we did here, right? So we substituted negative 1 in here. It's looking like a little 6, so it's not a 6, right? We substituted x is equal to negative 1, and we ended up getting y was 0. So that means the entire point was negative 1, 0. So we have our point now, and we have our gradient. So we proceeded to find the equation of the normal, right? So we substituted we substituted the y value, which is 0, substituted x, which is negative 1, we substituted our gradient, which was also 1. And we went ahead and we worked that out, and we got our c value as 1, and then we just filled in everything here. Okay guys, so here we have example number 3 now. So basically it's the same thing, right? So they want us to find the equation of the tangent to the curve. Y is equal to 5x squared plus 6x plus 2 at x is equal to 2. Alright, so the first thing we need to do, right, we need to work out the gradient of the tangent, right? So gradient of the tangent is dy dx. So first we write down what y is. Y is equal to 5x squared plus 6x plus 2. Then we work out dy dx, which is, this is a 5, right? 5 2s are 10, x plus 6. They say x is equal to 2. So when x is equal to 2, dy dx would be 10 by 2 plus 6. 10 to 20 plus 6, which is equal to 26. Right? So the gradient of the tangent is equal to 26. Right, so they asked us to work out the equation of the tangent, right? So we have the gradient of the tangent, which is this here, right? So we have the m value. In order to work out that, we need to have a point. We know the x part of the point is this, we need to work out the y part of the point, right, to complete the point. So when x is equal to 2, we're going to work out the y part, right? So we're going to substitute x is equal to 2 here. So we're going to get 5 by 2 squared plus 6 by 2 plus 2. Okay, so we're going to get 2 2's are 4 plus 12 plus 2. 5 4's are 20 and 12 and 2. Okay, so we're going to get, make sure you guys can see that. Right, so we're going to get 32, 34. Yeah, we're going to get 34 here. Right, so the point is point is 2 and y is 34. Right, so we're going to actually work out the equation of the line. So y is equal to mx plus c. Y is 34, m is 26, and this is 30. No, this is 2. Right, so we're going to work out that. So we're going to get 34. Let me just draw this line here. Is equal to 26 by 2 plus c. So 34 is equal to 26 by 2 is 52. 2 2's are 4, 1 is 5. Yeah, 5, 52. Okay. Let's try this out neat. So 34 take away 52 would be our c value. Okay. So that will give us negative 12 take away 4 is 8. It's 2. 4 take away 3 down. So negative 18. Okay, so we have negative 18 is c. So now just to write our answer. Y is equal to m. M was 26. 26x take away 18. Right, so this is the equation of our tangent. Okay, so let me just kind of recap this one now. So they asked us to find the equation of our tangent to the curve 5x squared plus 6x plus 2 at the point where x is 2. First thing you need to find is the gradient of the tangent. The gradient of the tangent is dy dx. So you work out dy dx, substitute 2 because it says specifically where x is 2. We got 26. Right? So that's the gradient of our tangent, which is our m value. Now in order to work out this is the gradient of our tangent. So in order to work out the equation of the tangent, we need to have the m value plus we need to have the c value. But in order to get the c value, we need a point and the gradient. So we worked out our y value for the point, which worked out to be 34. Then we substituted the entire point, the y, the x, and we substituted the m part and worked out the c value, and then we just substituted back into the equation to get the answer.